With your pin setup complete, you are now ready to define DUT power in the Power Setup section of the main window. Enter desired DUT supply voltage, VCC, and current limit, I max. The DUT power supplies installed by default are, for supply 1, 0 to plus 8 volts at 2 amps max. For supply 2, 0 to plus minus 16 volts at 1 amp max. For supply 3, 0 to plus minus 16 volts at 1 ampere max. For supply 4, 0 to plus 3.7 volts at 4 amperes max. You can verify the voltage ranges of your supplies by clicking Inventory on the checkup sidebar, and find the Power Supply tab. Sequencing defines the power up and power down sequence for DUT supplies. It is especially important for devices with multiple power rails that require power to be applied in specific order. On-off delay per supply adds more delay between turning on and off power supplies. The ramp button defines custom ramp up and ramp down for the DUT supplies in cases where advanced power sequencing is required or for special types of tests. In the measure, you can quickly do IDD measurements. Check the box for each power supply you want to measure. The single button runs one measurement. Continuous opens a new window where you can define your own settings for free-running IDD measurements. Symphony allows you to make current IDD measurements on your DUT in a continuous mode. The latter is done by allowing the DUT to free run, that is, to execute the test vectors continuously and take samples of the IDD on the fly. Click the Continuous button on the DUT power window to display the continuous supply measure. To acquire continuous IDD results on supplies, select Supply and click the Start button. Measurements will continually be recorded and averaged until you click Stop or Clear. Note, the DCPMU use separate definition for IDD test setup. If your DUT cannot tolerate a rapid rise of VCC on power-up, click the Ramp button on the DUT power window to use the Power Ramps control feature. Power ramps must also be defined if you plan to use the liquid crystal IDDQ hotspot feature. First, enable ramping. Select the power supply for which you want to save the ramp settings. Set voltage and weight values for one step of the ramp. Click to add a new position for the power up sequence and power off sequence. Double-click on the position to delete it. You can set the weight value and click on the Default button. Lists will be automatically generated with voltage steps of 10%. To save, click Done. Liquid crystal IDDQ hotspot, traditionally used as a failure analysis tool, employs the rampability of the DUT power supplies to apply a precision-tuned pulse on VCC pins while the surface of the exposed die is observed. Its name was inspired by liquid crystal file used to observe temperate gradients on DUT die. Nowadays, other thermal imaging techniques are used, but the principle remains the same. Access the feature by clicking the IDDQ hotspot icon on the FA support sidebar. Before using hotspot, you must define power ramps as shown before. Select the supply and low percentage of VCC that supply applies during the low phase of each pulse. These times are applied to the pulses defined in the power ramp window. The system will run to this vector before beginning PWR and PWR low pulses. Before start, be sure that logic levels are set as percentage and not volts for all assigned pins in groups. Then let's go back to IDDQ hotspot window and click Run. As the test executes, the measurements are updated below. You may hear the measurement relays working in the system. Important note, connect the test box before starting the test, or you will not be able to stop collecting data. When you start the test, results will be saved in the ASCII file iddq.log and will also appear in the window. You can read here V, C, C max, and MIN for the hotspot pulses. IDD as measured at VCC set in the DUT power window under conventional IDD measurement conditions. These values are dynamically updated with every loop of IDDQ measurements. Watch it changes each time that IDDQ is measured. If more than the 4 internal DUT supplies are needed, you can use additional power supplies on pin electronics boards installed in the system if PMI 32 option is installed. These supplies are independent of the main DUT supplies 1 through 4. Click the PEBPS button to display PEB power supplies window. Use 1 to 8, 9 to 16, 17 to 24, and 25 to 32 tabs to select the PEB ranges displayed in the window. PEB supply shows PEB number. Use voltage and current fields to set voltage and the current limit for each supply. Each PEB supply can provide 0 to 8 volts and up to 1 amp. Then, check Connect for the supply output to enable it. If you uncheck this, the values remain, but the supply is disabled. These all settings are stored in your set file. Be sure to save your setup when done. For external voltages and current limits over the system capabilities, you can use external power supply option and control external power supply over GPIB and USB. Check our another tutorial video to learn how to use it in the Symphony.